Okay, so I wanted to make a quick short video about some of the homework problems here, specifically these problems 25, 26. These are more of a definition. This one was asked from my Wednesday class here. I felt I kind of gave a short answer here, and so I wanted to just go back on this. So probability of E and F, if that equals 0, that means that the events are mutually exclusive. So that means they can't both happen at the same time. So you're kind of in one or the other, so there is no intersection in that case. So your picture looks somewhat like this, right? E and F, where they're not happening to each other. And so we recall the definition for conditional probability. It's a probability of E and F here over the probability of F. We've been doing it a bit more intuitively with the charts, but using the definition, again, you could think of this as kind of a divided by F. And so that's what goes into the denominator, that probability of F in that case. And so here we get 0 over 0.3. Since they are mutually exclusive, it states it there. We know that guy's going to be 0, and that's where that 0 is coming from here. And then that 0.3 is just from right there. So we get 0. Here's another definition. If events are independent here, then probability of J given K is just going to equal to the probability of J. And so the reason is if they're independent here, then it doesn't matter what happened prior to it. So this is the probability of J given K already happened. But if it's independent, it doesn't matter what happened before. So it's really just the same as saying the probability of J again. So these guys end up being equal whenever we have independent events. So again, it's more of a vocabulary thing here. And so we have the probability of J given K is just going to equal to the probability of J. And we know that's 0.1 given from right there. And kind of a plug and chug at that case. All right. Also asked, I believe in my Tuesday, Thursday class, was problem 28 here. And so let's look at this one real quick. We're looking at the probability that here distant learners, on my example, it's 0.10 there. And then it's also giving us here what's being underlined here in green. Probability of E, and so E is going to be that they're a part-time student, and that's going to end up being at this 0.20. And then here we have the probability that's a part-time student, and then it says 20% of those have taken a distance learning. So really what that's saying is the probability you're a distance learner given you're a part-time student, because this is talking about of the part-time students right there. So they didn't actually say the phrase given. The wording on it was a little bit weird, but that's what they meant in this case here. And so that's going to be 0.20. Some other algebra stuff here. If you do the probability of D given E, here's our formula for this over that. Now, if I wanted to rewrite this and solve it, if I have a fraction, I have to multiply both sides by the denominator to create a factor of 1. So if I multiply both sides by probability of E, on the right side, I get that factor of 1. And so I have probability of E times probability of D given E is going to equal to the probability of D and E. And it's just another way of rewriting this. So that's going to just help us out so we don't have to do all this algebra again to just kind of write it in that format here. So I'm going to use that version of it. So probability of E times probability of D given E is equal to the probability of D and E. And this guy here is going to be 0.20, and that's a given from right here. And then this conditional one, that's going to be given from right here. And then I'm just going to multiply those guys together, and I get 0.04. And those are my answers there, what's in that green key there. Here we're going to use our formula again, starting off with it. So we have our general formula here. Now the probability of E and D is actually the same as the probability of D and E. So this guy and this guy are the same because we're just looking for an overlap. It doesn't matter which is which event, which one we write first. So that one's going to still be 0.04, and then probability of D is going to be here, which is 0.10. And so that gives us that answer there of 0.4. Okay, so now we're going to use an OR statement here. And again, this one has a formula here, probability of D or E. If you recall, it's a probability of D and a probability of E, but then we got to subtract any overlap that we have between these guys here. And so now it's kind of just a plug and chug thing here. There's probability of D. Probability of E is right there. And then we have D and E, which was right here, right? And then we're getting 0.26. And then down here in part D, again, it's more of the definition stuff. So as we said, if we have a conditional probability and it's just equal to that first part, this is going to say that D and E are independent. And again, it has to do where if we're saying, probability of D given E, but if they're independent, then it doesn't matter what happened with E. It's like we're starting over again. So it's just going to be the probability of D. And then here again, another definition thing, probability of D and E is equal to 0 if things are mutually exclusive. And again, we could just look at that Venn diagram where we see they are, there's no overlap or no intersection between these guys. So the probability is just going to be 0. Okay, I hope that helps out. I'll end that there.